Number 13 was designed to be one of those special right triangle problems. So it's a right triangle where the two legs are congruent. Um, it's isosceles right, then. So if we've used up, say we've used up 90 degrees out of our 180 from any right triangle. The remaining two angles have to be equal, base angles theorem. So 9 divided by 2 is 45. So x is 45 degrees. Didn't have to use trig to do that. Could have, but didn't need it. All right, so next one. This is the cofunction problem. Cofunction values are equal, and here's the theorem. When their angles add to 90. So sine of 22 should equal cos of 68. Why? Let's say we call that x for a second. What we should be able to do is say 22 plus x equals 90. Sine equals cosine when those two angles add to 90. So we're going to subtract 22. Most of you won't do this with algebra. You'll just take 90 minus 22 to get 68. So, and that's fine. Plenty of work. If you said 90 minus 22, that's plenty of work to get full credit. Might need to explain it a little bit just to be safe. It'll be a 2-point question though. In that right triangle, okay, I worked out this one ahead of time. This one's really mean. So this whole time, what we were trying to teach you was if sine A equals cos B, and what we're saying is C is the right angle, right, in triangle ABC. What we're trying to teach students is that this happens because A plus B is 90. These two angles add to 90, so their cofunction values are equal. Well, now they're going into some weirdness here. Okay, so let's just write this down. We're supposed to know that sine A is the same as cos B. And these are extremely, this is an extremely mean problem because I don't want you to set them equal. Like, let's say this were the problem, or we did a question like this. So we did one like this in our notes, right? And sine and cosine are equal when their angles add to 90. It was really a challenge to get us to say, add these to 90 instead of setting them equal to each other. Okay, this was the right way to go. This is what I tried to teach you earlier on this problem. And we carry that out. You know, we'd finish this. This is in our notes, but I'll do it combining like terms here. I want to show this because I think it's really important to go back over this concept. So what we would get is an x equals 20, okay? Then that, when you plug back in, plug 20 back in, you get sine 50 is equal to cos 40. And that's what we have taught you. Cofunctions are equal when their angles add to 90. Now here it is. They're going a whole different direction, a much more challenging problem. This is a lot like a problem on the SATs. We know sine A is equal to cos B because these two angles add to 90. Okay, so now they're suggesting that we replace sine A with this, cos B with that. Now here we go. I was trying to teach you on this problem to be careful. Don't just blindly add them to 90. I'm sorry, don't just blindly set them equal. We should instead add them to 90. Well, that's if it's this problem. Now we're actually saying sine A is replaced with 2x plus 0.1. Cos B is replaced with 4x minus 0.7. So now I am telling you to set them equal. And this is a totally different scenario than this. So, a little confusing, very tricky problem. Um, so I hope we're careful on that one. Yes, this could be what's on there, what's on the test, but who knows? Okay, so let's just be prepared. This is extremely mean, but it could happen. You got to be ready for it. So that's what we're looking for. Explain your answer. Okay. Now, whenever it says explain, it's not sufficient just to show our algebra work, even though it's very good. That work is very good, but it's just not going to cut it. Okay. So nobody's going to let you off the hook with that. Okay. So our explanation is sine A equals cos B because A plus B equals 90, and cofunction values, we'll just kind of state the theorem here. Cofunction values are equal when their angles add to 90. Okay? And that's because of the diagram up there. All right. Next, by substitution, we replace sine A with, what was that? 2x plus 0.1, and cos B with 4x, what? Minus 0.7. So set those equal and solve. Get x equals 0.4. Very challenging problem, but we can handle it. All right, why is cos x equal to sine 90 for all x such that x is between 0 and 90? Okay, so we know that x plus 90 minus x equals 90. Key is plus there. Now, when angles add to 90 degrees, because we're going to be careful. Someday we're going to talk about radians. Let's make sure it's degrees. So when angles add to 90 degrees, their cofunction values are equal. That's it. That's the theorem. All right, now 17 on, we're doing problems where you have a right triangle, big right triangle with an altitude drawn from the right angle to the hypotenuse. Doesn't look like that, but think it through what we just did. The way I want you to do these is we're going to separate the diagram. Okay, so I'm going to take this triangle right here with the 5 and the right angle and the y. I'm going to separate this medium-sized right triangle, okay, with the 8 and the y. Now, there is one big triangle as well. Okay, we won't use it, though, in this problem, but there's a big right triangle right here with a 13 at the hypotenuse. Now, for number 17, what we have to recognize is for the smaller right triangle, the leg on the hypotenuse, the piece on the hypotenuse is always smaller than the altitude. So this is the smallest leg of the smallest triangle. The corresponding smallest leg on the medium triangle is the altitude. We've got to memorize that. Nothing we can do about it. The bigger leg on the small triangle is the altitude, and the bigger leg on the medium triangle is over there. We've got to match those. We've got to get corresponding sides. The key to these problems is to make sure we know which ones are the corresponding sides. Now, the way we indicate those is hopefully we're going to teach you to use your highlighters, right? You're going to bring highlighters to tests because we're going to do things the right way. So that's what we're going to do. So we're highlighting the corresponding sides, circling the corresponding sides, whatever you want to do. So 5 over y, because those two are corresponding. And then we're going to put these on top the whole time. So y, this y over that 8. Then we'll cross multiply. So y times y equals 5 times 8 and it doesn't say simplest radical form or round or anything like that. So I'm just going to leave it square root of 40. I'm prepared for them to give me simplest radical form or nearest tenth. But that's the answer. All right, same problem, three right triangles, right angle in the corner. So what I have, it's a little bit tricky to draw. Okay, so what we have here is the bigger of the two triangles here. That's going to be 6. You got to figure that out, with the hypotenuse being x. Now the small one, which we're not going to use, and you'll see why in a minute, has only the 2 involved right now. Okay, we could figure out the altitude, but we don't have to. There's a better way. So what we're going to do is then we're going to use this big right triangle that has x here and 8 here for the hypotenuse. Now this is really easy to match up. I always circle the hypotenuses when I'm going to use those. Got the hypotenuses, very easy to identify. Don't really have to mark the angles. Now, one way we can manage this is say that's our corresponding angles. So you can see the 6 is corresponding based on the angles positions to that x, right, between the single marked angle and the right angle. So this is another way we do this. Now remember, the whole point was we're going to use the corresponding sides to write our proportion. So 6 over x equals x over 8. And now we have x times x equals 6 times 8. And same thing happened on this one. They're not telling us what to round to, so I'm not going to round. They're not telling us simplest radical form, so I'm not going to take any chances. It's 4 square roots of 3 if you do that for this one. Go back up here, this one's 2 square roots of 10 if you put in simplest radical form. Last one, let's see. Okay, so for this, I'm probably going to use Pythagorean theorem to get z right away. Okay, but let me just redraw it. All right, I'm going to redraw that side. Okay, I'm going to slide this down, redraw that. Oops, a little too far. And then the big one. So this is y here and x and 12. This is 12 here, 16 and z, y, z, x plus 16. I probably won't use that one. But the reason I'm going to take care of z first is because I can go right at Pythagorean theorem with that. So I'm going to, I'm going to get that out of the way right away, and then see if that makes some of the other problems easier. So being the right angle there, that's the hypotenuse, that's going to be bigger. So I'd go 12 squared plus 16 squared equals z squared. If you know your triples, it's 20, but we'll work our way that way. 144 plus 256 is 400. Then we square root both sides, and we end up with 20 for z. And so that gives us a side here to work with. Okay, so now we get the 20. Now we can start matching them up. All right, so this is the smallest leg of the small triangle. Actually, you know what? I always like to go with hypotenuses first, right? That's easy to identify. So I'm going to circle that one. This is the hypotenuse on this side. I'm going to circle that one. Let's get rid of that right there. All right, now I'm going to highlight. Well, wait, one more. Circle that one because there's a right angle. Let's highlight in yellow the smaller leg, right? So that's a smaller leg of the small triangle. That's the smaller leg because obviously 12 loses to 16. And it looks like, yeah, y is probably smaller. It's definitely smaller. Okay. Now, of course, 12, we'll put that in blue. 12, 16, and 20, those correspond. So what I'm doing right now is I'm just getting the corresponding sides. It takes some work to figure out which ones are corresponding. There's lots of methods. People will memorize those. They'll get some kind of SAS help hall. I've heard of them all. And the bottom line is it's going to be work to make sure you identify what the corresponding sides are. That gives us our proportions. Let's say we're after x next, and let's see if we can, get a proportion going. I like x, if we put this on top, x is to 12, right? They're both in yellow, so they're corresponding. And then both in blue, 12 and 16. Okay, so 16 times x equals 12 times 12. Of course, that's one of those that are really popular and you probably already memorized. So you probably did this with no work at all. But this is how I make sure I match them up. Now I want to go for y. So I'm probably going to, yeah, y with 20 looks good. I think I can get that done. If we go y with 20, 12 with 16, we should be all set. So yeah, y with 20 and 12 with 16. 16 times y, 20 times 12, divide by 16, and what is that? So that's 15. So what we have is x is 9, y is 15, z is 20. Sorry, I went a little over on this one. That'll be it for this video. Hopefully we can finish up on the next one.